Hello. Today we're going to talk about scaffolding, what it is, and how does it correlate with education, and really just about anything that we do in life. When someone says the word scaffolding, what probably comes to your mind, just like most people, is the construction scaffolding, those metal poles and little wooden flat standing boards that you see on the outside of a building as they build it up. So a more defined definition is scaffolding is a temporary structure on the outside of a building used to help build a actual structure. Now, on the lower levels of it, it's going to be attached to the floor. You're going to the actual base around where the building is being built. And then we're going to build up on the outside of the building so that as we build on the interior structure, we can also start to fold the exterior building in to complete it. Now, you're probably wondering, like, how in the world, Chief, does this translate or explain education, talking about like this wooden structure? Well, the term was first used in Wood et al. In 1976 to describe how an adult or a more knowledgeable peer might assist a child to learn something within their zone of proximal development. Or, put another way, scaffolding is teaching a method that involves providing support to learners as they learn new skills or concepts, and gradually removing the supports as they become more competent. So essentially, we kind of build a safe structure and easy base for you to kind of learn the basics of something. And it creates a foundation in which you can start to build upon that knowledge, right? So that we're not just like immediately starting you with like calculus. So again, think of education kind of like a building. Before we can begin building on the second or the third floor of that building, we need the foundation or the first floor of it, right? And much like that building, as we build up on it, as we build into that education, building on that building as it gets to the fourth, fifth, sixth floor, it's going to be much more difficult to, one, add information to it, and to work on that information if the bottom structure isn't properly built, right? Like imagine trying to put a roof on a 6-story building, but the base is wobbling. So that's why we would use scaffolding to really make sure that we build that structure up nice and good. We get to the top and we continue to work in nice, safe environments, just like in education. Scaffolding, and we really kind of start to break down and narrowly think about, okay, how do I actually apply a principle like this when I'm teaching a kid something? Well, as an adult, we also benefit from this amazing thing called metacognition. Very quickly, metacognition is just the process of becoming aware of something makes you better to be able to understand or deal with the situation in the future, especially when it comes to like a reoccurring event or something that is coming up specifically that you can plan for. A great example of this is like instant wealth syndrome. People that like win the lottery or like come into like large settlements, and they're not previously exposed to that type of wealth, sometimes they'll end up overspending and they actually end up putting themselves into a more significant financial hindrance than before. But being aware of instant wealth syndrome and how that can affect you can actually help you mitigate or reduce those effects. So now that we've kind of like brushed over exactly like what scaffolding is, kind of on a baseline of like how we're going to help provide information to our peers or to students, let's actually look at some examples on like how we would do this. All right, so the first example that we are going to look at is an example of new math. Now, I'm sure you guys have seen or heard a ton of complaints from different people about this and how they think it's probably not the best idea that we're changing math or something of that sort. And at first, I was actually probably one of those people. And then as I started to examine it, I realized that a lot of this is actually how I do math in my head. So we've got 37 here. And you can see that obviously this isn't an easy whole number, especially when going right here with this 55. So the best way to do this would be to separate into the 30 and then into the 50, and we know that's an instant 80, right? And then all that's left over is the 7 plus 5, which is 12, and then that gives you 80 plus 12 gives you 92. So it actually helps break that down real easy. But how does this fit into scaffolding, right? Because this is just like basic addition. After this, like, where is it going to help? For me, the best example is in fractions. Well, I said fractions, but I actually meant decimals. My apologies. So let's say when working with decimals, right, like we're trying to figure out how much we need to tip our waitress when we're out at dinner, right? So we'll say our bill comes up to $36.44. All right. And we're trying to give a tip, round it up to $50. Okay. So what I want to do is the first thing is I need to get this up to $37 because that is going to be much more manageable. So I know the difference is cents here, right? So the first thing that I need to do is get this to something I know real easy, right? Half of 100 is 50. So I've got 44, 50. If I minus those, I get 6. And then I had 50 left over to make that 100. So the answer there is 56 cents. And then I look at 37 minus 50. And what do we get? 13. So right there, I've got my tip. And I'm rounded up to the 50 that I wanted. So that's kind of how building on that old math will help us do things like this in our head as we get a little bit better. Now, the examples don't just stop as far as like actual individual instruction or information. Some of it actually has to go with just the simple rules that we teach because they help build a structure in which a kid's understanding can develop on. So you can see in this Reddit post, a guy talks about my son's 3rd grade teacher taught my son that 1 divided by 0 is 0. I wrote an email to tell her that it is not 0. She then doubled down and then CC'd the principal. The principal responded saying the teacher is correct. What do I do now? And he says that he's infuriated. He's not sure if he's overreacting. Should he stop fighting this battle? And then the teacher got back to him and admitted her mistake, which I'm grateful for. She said she was taught 1 divided by 0 is 0 back in the 90s. And that's because they were doing proper scaffolding. Because if I tell a 3rd grader that 0 divided by any number is 0 and 0 times any number is 0, and then the same thing as far as rules with a 1 times that number equals that number, or 1 divided by that number equals that number, then I tell a kid when we get to 1 times 0 or 0 times or divided by 1 that now that doesn't work, that it's undefined. Instead of a kid being able to process that information and move about, we're more than likely going to have to sit there and kind of try and like work through it. A kid, you're going to literally see the gears inside that kid's head just like come to a halt. They're not going to understand it. Some of them might, but you're going to have a lot more difficulty trying to address and further along the education if you're getting stuck on little minute things like this that don't actually have any applicable principle. Like, there's no way in which arguing that 0 divided by 1 is undefined, in no way does that benefit anyone, especially a 3rd grader. Like, the fact that this dude went in and that people like followed up on this, like, oh yeah, you're such a champion. Like, this is an example that you don't actually understand how education is done. So that was the purpose of this video. And so that's going to be the conclusion of our first video, scaffolding, as part of our rational thinking series. Thank you, and see you again